guys, welcome to another episode of Cuda Education. Today, we are back on the grind, trying to figure out ray tracing glTF. Um, so, couple of things is that really and truly, of all the ray tracing algorithms that we have done so far, this ray tracing glTF is quite different. It might be even our most involved, sort of intricate algorithm of all the examples so far. So I think the only one that I haven't really touched on is ray tracing textures, which I don't think is all that complex, but I might be wrong. But this ray tracing glTF, it's quite a lot of stuff going on. And, I'm kind of trying to debate, what's the best approach to tackle this mountain, right? What's the best way to go about it, right? I kind of been just brainstorming, trying to figure out, what's the most straightforward way to attack this thing. So as a first attempt, right? And maybe we'll halfway through we'll do something different. But as a first attempt, what I plan on doing is maybe just attacking these shaders associated with the algorithm. So this algorithm, as I mentioned before in the previous video, this algorithm, it has 1, 2, 3, 4, 5, 6, 7, 8 shaders associated with it, right? 8 separate and distinct shaders. This is assuming the GLSL language and using those set of shaders. Obviously with slang is a little bit more, it's a little bit more capable, so they combine things and all of that, right? But it's still separate stages, right? But we're running with GLSL because that's what we've been learning so far. And the thing is that we have all these shaders, so as a first attempt, what I'm gonna do, so we'll just run the script as is, right? So we have the anyhit shader enabled, and we get our flight helmet, right? Now the thing that we have to notice about this one is basically that notice that we have these goggles here and we could see through the goggles, okay? So that is the the biggest thing that's going to be affected when we disable the anyhit shader, right? We could see through the goggles, okay? Okay, so we could see through the goggles, okay? So that is that is the anyhit shader. So what is the anyhit shader? The anyhit shader, it's basically the shader that deals with transparency, right? So in this case, we're dealing with the goggles and we hit something, right? Because the goggles is made of plastic, right? The goggles are made of plastic, right? So we hit something, but the anyhit shader says keep going, right? Keep going until you hit something else, right? So it deals with opacity or transparency of an object, right? So I don't think I could necessarily, I don't know if there's anything else on the model that will show any other transparency, but right. So we have our transparency with the goggles, right? Now, the thing is, if we disable the anyhit shader, so now we're disabling it. We commented it out, all the things dealing with pushing the anyhit shader into the shader stage, and we basically declare that shader group anyhit shader is VK shader unused. So we're not using it anymore. Okay, so we've completely disabled the anyhit shader, right? We're not calling the sphere V file. We're not calling the sphere V file or anything, right? Now let us run this example and see what happens. So we now have our anyhit shader, but notice that the goggles are completely opaque, right? So if you hit something, assume that it's opaque, right? And don't proceed further. Don't do anything. Just assume it's opaque, and that's it, right? So remember, each pixel represents a ray that's traversing the scene. So the first thing you hit, just assume it's opaque. Don't traverse any further. Don't look through it, whatever. So we get this, right? That is my understanding of the anyhit shader. Even when we go on the other side, we still get the same effect, right? We still get opacity. All right. So that is my understanding of the anyhit shader. All right. A couple of notes for you guys. I attempted to, so let me put back the anyhit shader, so what it was, and we'll run it again just to make sure that we are good to go. I'm back to basics, right? Back to the original, right? So we now have our anyhit shader going again, right? We now have our anyhit shader, right? We could see through the goggles. Right? Okay. So a couple of things. I attempted to try to recompile, because remember, guys, when we're dealing with shaders, I always have to recompile the shader to sphere V format, right? I tried to recompile. I tried to basically disable, because in the shader we have this main function, right? So I tried to just remove everything in main, right? So everything, would remain the same, but we just wouldn't actually execute anything. I tried doing that, but the way how the compile shaders.py file is in the GLSL folder, based on what's default of the application and the solution. First of all, it doesn't even attempt to compile a .ra hit file. That's the first thing. And then, even when I add this extension to compile shaders.py, it creates a compilation error. So I tried doing it with leaving everything as the same, but just not using the actual commands in the anyhit shader, but that didn't work. So I had to basically do it on the on the code side, on the shader stage side, by disabling it and doing the VK unused, doing the VK shader unused flag, right? So that's just a little note, right? As it relates to this thing. But that's all right? So we disable the anyhit shader, and we kind of now have an understanding of what the anyhit shader does. Now notice that we also have a closest hit shader, so that's another shader that we're gonna have to investigate and figure out what exactly that does. I'm gonna assume it's more along the lines of what all the other hit shaders do, right? So if you don't hit anything, you're not gonna see anything, right? That would be the general logic, but we'll have to wait and see. Remember, this is a different kind of situation we're dealing with, so we have to basically, we can't assume anything. We have to basically run through the motions and see what happens, right? So we have one shader kind of conquered, because we kind of understand that if we disable it, we don't have any kind of transparency, right? It's actually a big deal, and it's actually a big thing in computer graphics. I am not going to get into the details of this shader right now, right? That's not, it just wouldn't be wise to really try and tackle it right away. Yeah. Let's look at this. If the alpha value of the texture at the current UV coordinates is below a given threshold, we'll ignore this intersection. Right, so we kind of ignore that way ray traversal will be stopped and the mist shader will be invoked. Yeah, okay, but there we have our threshold. I really don't want to start messing with this. Well, I can't actually, because the compilation problem I have. Maybe I could go into the sphere v file itself and try and modify it that way, at least this number, but I'm not gonna do that right now. But basically, that's what this guy is, right? We're trying to, decide if we hit something, is it completely opaque, or is it something that we could continue to traverse to see what is behind it, right? What is transparency to it? Wouldn't it be great if you had eyes like that, where you could just kind of, like if you had a wall, you could say, hey, I want to see what's behind that wall, and make the wall transparent with your eyes. Wouldn't that be cool, guys? But yeah, so we're not gonna go down that path right now. But yeah, notice that we're making decisions here based on threshold and all that stuff, right? And we're deciding whether to ignore intersection, right? So that's basically what the goggles is. We're going to ignore that intersection and continue to proceed with the goggles. Okay. We include a bunch of files. So notice that we include, so with the anyhit, we include buffer references, geometry, and random. Okay. Not going to get into that right now, but so that cuts down the number of shaders that we have to tackle. If we just basically say, okay, all that is just for anyhit, and we'll just combine that into anyhit, then it cuts down the number of shaders that we actually have to tackle. But we'll have to investigate what these other things do and why it has to be included in the anyhit shader. Okay. So set up ray tracing shader group. So notice that this is part of the shader group discussion, right? So we have the closest hit for texture lookups, and then the any hit shader part. Shader binding table layout, raygen, mist plus shadow, hit plus any. So we have the mist plus shadow, hit plus any, right? So we have a lot more stuff going on here. But yeah, guys, this definitely is a different cup of tea. It's probably the most complex thing in the ray tracing examples. Although, I mean, ray tracing intersection was pretty cool too. The procedural spheres, remember we're dealing with all the spheres and stuff. That was pretty cool. But I wouldn't necessarily. I mean, I think it was concept heavy, right? It was a lot of concepts that you had to understand in order to like appreciate how things were being made and what was happening. So between this and the ray tracing intersection algorithm, and they're right beside each other, funnily enough. Between those two, I would say is the most complex. But yeah, again, guys, I'm honestly, for the ray tracing stuff, it's really not that complicated. Once you understand the terminology, the vocabulary, what things mean, and why you need these things, then it becomes very straightforward. You know, that's pretty much ray tracing for you. So anyway, guys, I'm going to continue on the journey and, of course, carry you along. We're going to have to figure out what the other shaders do, right? We're going to figure out what the other shaders do. And then I'll probably tackle the main, the main file, the CPU side files for this example. I think that's the most straightforward way to do it. But I might jump around too. We'll see what happens. But we've done the anyhit, maybe we'll I don't know which one I'll do next. I guess I'll do the hit next, right? But we'll see. Anyway, this is Cuda Education, guys. You know the deal. You know the deal. You know the deal. Tutorial number 1 and tutorial number 13. Tutorial number 1, install the Vulkan API. Tutorial number 13, install all of these examples. I assume you have a ray tracing capable, Vulkan capable GPU. So the GPU has to be Vulkan capable and it has to be ray tracing capable if you want to run the ray tracing examples. If it's just Vulkan capable, you'll run all the other examples except for the ray tracing examples. I also assume a Windows machine. So we need a Windows machine, with a Vulkan capable GPU and a ray tracing capable GPU. If you have an NVIDIA RTX card, if you have the RTX series card, you're good to go. RTX and later and greater. I don't know what the next iteration of cards are going to be, what they're going to call them, but NVIDIA RTX cards, if you have those, you're good to go. I can't talk about the other AMD and Intel GPUs, right? But yeah, guys, computer graphics is pretty cool. If you're commuting back and forth from work, if you're on a train, if you're on a bus, and you have time to kill, it's definitely worth learning this stuff. All right. Thank you guys for watching. This is Cuda Education. Have a great day.